take a look at this problem here where we have something called a conical pendulum that is moving around in a circle. So this would sort of sweep out a cone instead of just a pendulum swinging back and forth. It moves in a circle as it goes around. And so the question here is, if we have this unknown mass moving in this circle, what would its speed be based on the given information? All right, so let's go ahead and put some forces in our diagram, sort of see what we have to deal with. So we have the weight force, and then the only thing touching the mass is the rope. And so that would be the only other force acting. Well, since I see I have an angle in the problem, and I can see that my forces do not correspond to just a single up and down direction or left and right direction, I certainly am going to have to deal with both an x and a y. So I would want to consider F equals ma in one direction where there is an acceleration, and then I'd want to consider all of my forces balancing in another direction. Okay, so in this case, our inward direction is this way. Okay, be very careful about this. That inward direction has to do with the circle, doesn't have to do with the string. And so it corresponds sort of to this dashed orange line here that I'll explain in a second. So that's going to be our positive direction. That's going to be our direction of acceleration. And then our forces that are perpendicular to that are going to balance, because the object is not accelerating, it's not even moving in that direction. So what I did here is took the tension force and split that into two components. A component that was along the same direction as the acceleration, so that I'll be able to work with this equation, and then a component that was perpendicular, which I'll use for this equation. So let's see how this works out. In the direction where there is acceleration, I would use this side of the triangle, so that's the opposite. Hypotenuse times the sine would equal m times a. And then again, because I'm moving in with this constant speed, I can substitute the v squared over r instead of my acceleration. Then in the other direction, in the perpendicular direction, these forces have to balance. So taking up to be positive, ft times the cosine of theta minus mg would have to equal 0. Of course, you could also just set those two forces equal to 0 if that's the way you like to set up your problems. All right, so I don't know the tension force, but I can use these two equations to substitute and eliminate that variable. So I'll solve the equation on the right and substitute that into the equation on the left. You can kind of see a tangent sort of poking its way up here. My masses can be canceled out, and I can rearrange things just a little bit, and we find that the speed of this object would be 1.7 meters per second.